Hey guys, welcome to the Dev Method. My name is Ricky. We got a live stream today, and we're gonna do more Rustlings. And I don't know, but it seems like it's very different than 100 exercises to learn Rust. So we're gonna compare the two, maybe even compare a third, just to see like which one is good for what you're looking for. But yeah, we're just gonna get through some of this today. So if you want to follow along, you can. Let me switch over real quick. Let me just show you the website. So it's rustlings.rust-lang.org. So you get to this website and you can follow the instructions, watch a little video here, but I'll show you how to get started here. So these were the installation instructions. It is kind of assuming that you know how to install cargo and stuff, but there is, if you go to setup, I'll show you here. It shows a couple more things, like what you need in terms of setup. But yeah, if you have questions, just ask in the comments if you're watching this later, and I'll help the best I can. So yeah, other than that, let's see. All right, so let's get started with the first thing today. What do I have to do again? I go to just Rustlings. Okay. All right, don't know what's going on there. Close that up. Yep. Okay, so let's go to, here we are at Rustlings. Let's see, how big is this? All right, so if you didn't see in the last stream, just to give you an idea of what we're looking at, so it's just a bunch of different exercises to learn Rust, everything from like very beginning to probably beginner of intermediate, I'm guessing, but we'll see. We'll see how tough or hard this gets. Essentially what's happening is that when you run Rustlings, it's running, it's keeping like a little mini micro database of where you are in the process, and then it's running that project or that exercise that it is assuming that you haven't done yet. So it's meant to go in order. So it says the current exercise here is found in the exercises folder 04 primitive types 1.rs. So far it's been a lot of compiler errors, so you're meant to go fix them. And there's a lot to look at here. So, you know, just as an example, you could actually search this error number here and read more in-depth information about it. But here it's showing you the actual line of code and the file that it found the issue on. So opening up an editor and taking a look at that point would be, you know, a great way to go forward. There's also this here, rust C. So I would open up like another shell and work on your editor, and then like leave this one maybe off to the side. But that's what I do. So here I go. So we got the exercises. Let me make this just slightly bigger. And then it's under number 4, primitives. Actually, before we even do this part, let me show you the list. So there's a couple of, there's hint, then there's list, then there's check all, there's resets. I'm assuming that, you know, starts your progress back to the first exercise, and then there's just regular old quit. So if I hit L, you can see these are some of the things we've done so far. Just use the arrow keys up and down if you want to see what you've done. So we're currently doing this part here. So that's what we're doing. All right, so let's open up our other editor, primitives, types. There is a README here, so let's see what this says. Rust has a couple basic types that are directly implemented into the compiler. In this section, we'll go through the most important ones. So yeah, it does want you to follow the Rust programming book. Yeah, so like I have a bunch of different videos using the book's content as like an example of some of these things. I try and put my own twist on it where I can, where it makes sense, like with diagrams and stuff. But yeah, so I would suggest reading these things in the book as you go along, but I'm here now, so I can tell you maybe what some of the things are that it's trying to teach you. So typically you open up one of these files and it has a to-do, and then you go from there. So I'm reading the to-do, and it says define a Boolean variable with the name is evening before the if statement below. The value of the variable should be negative, or the opposite of is morning. So I think that what that's trying to say, if I was to come here, it's probably, and look at this, they give us a little hint here with the ellipsis. They actually use the ellipsis character. So be let is evening, and it's going to be the opposite of is morning. So I'll just use the bang operator there, semicolon. It inferred that it's a bool because we're already using a bool up here with is morning. Notice in my editor, I have a lot of these type annotations. So I didn't type this part, the colon bool. I could have done that, but I have type annotations on right now to show me the inferred types. So the types that Rust thinks I'm trying to use. So sometimes I'll turn that off so we can see what the true source code is right now, if I was to check this in. But otherwise, this is what I'm looking at here. So yeah, if I'm now to hide my editor and go back to the list or back to the exercise shell I have here at the top, you'll see that it, as I save the file or as I change it, it's rerunning the build or rerunning its check. And so here I pass that check. So yeah, so I'm pretty sure that this is just teaching us about bools and then teaching us like conditionals. So a true or false needs to go in your conditional. So yeah, that's what that's there. All right, so let's move on. Okay, so, all right, cannot find your character in scope. Okay, cannot find a value your character in scope. I can kind of get a hint from this that it is showing it's calling not only a variable that is non-existent in this exercise, but it has assumed some sort of fields or functions that it can call on it, maybe a method of some kind. So let's go down here, go to the next one. All right, note that the single quotes is different from the double quotes that you've been seeing. So yeah, that's a character. You'll see that inferred type there. Let's see, alphabetical, numerical. Okay, so analogous to the example above, declare a variable called your character. Okay, let's see, try a letter, try a different digit. Okay, it's saying just try different things. So that I'll show you here. This is yeah, so this is what we have today, right now. That's our your character is not in scope. So I'm going to actually uncomment this line. It does want us to put a character in here, so I can't have an empty character. Okay, so I'll just put, I don't know, B. So it's going to print out whether it's alphabetic, numerical. So it is alphabetical. So it is in alpha. But then it's saying try a different value here, and that's what that's going to be. And you'll see here at the top, I'll pull up the shell at the top here. So the first time it was alphabetical, now it's numerical. So let me do another one, and this should be numerical again. Oh, look at that. I can't put 10, but that's a good point. I could put a 1. There we go. Yeah, so it's a digit. Because it's a character, it's 0 and then 1 through 9. It's not like an actual bigger number. So that's actually a good thing to test there. But put in Z, that should be alphabetical now. So yeah. And if you see it listed twice, it's because we're printing here at the top as well. So it's saying that the capital C is alphabetical as well. So yeah, that is what that one is. So let's move on to the next thing. All right, so cannot find the value A in scope. So it's looking for a length in A. So let's do that. Create an array called A with at least 100 elements in it. Yeah, okay, so there's a couple ways to do this. So there's arrays, and then there's vectors. We're going to be talking about arrays first. So you might see this in like a JavaScript. I'm going to type it in JavaScript right now. And I'll call it A. And then you have this, and you can put all sorts of things in there, and you can even mix the types in there as well. And then that's like your array. So that's not exactly the same way that we're doing it here in Rust. So I'll have A here, but then if I want to make it a basically like an array, I need to do this, okay? Oh, actually, semicolon. I need to put the type that's in there, but then I also need to put in what the value of those types are. So I'm just going to use, let's say, just a bunch of 3s. And then how big is it going to be? I'll just say 100. So right now it's filled with 3s. That's what this first part is here. And then it's how many? And it's 100. And that's what that's saying there. Oh, but we still have an issue. Maybe what do we have here? There, okay, got to save. Just had to save. But yeah, so that's what that is showing. Now again, I have the type hints on there, so this is assuming that it's an I32, but I could make it like a U8 with 100. Now it's a bunch of U8s. Another way to write this too, if I just put the type after it, so I just put U8 here, then I don't need to put the specific type annotation there. Then it's inferred, as you can see with my virtual text there, that it's U8. So that's what that's saying there. So if I were to make this go away, so now it says, wow, it's a huge array, right? So let me make this 99 instead. All right, and then now it says it's a smaller array, is what it's saying. And what this does is just maybe to look at the other syntax that is here too. So we're printing out the line, yeah. We're also printing out a line here, but then immediately after panicking. So that means the main function doesn't actually return as expected. The execution just stops here. So that's what that's showing us right there. Cool. All right, let me correct that issue here. All right, so now we can move on to the next thing. Okay, so the next thing is cannot find the value, slice here. Okay, let's open this up. Let's see what is going on. All right. Okay, so I can already tell that we have a test here. I think this might be the first one in Rustlings that we see as a test, but this means that the configuration is for test, which means that this module is only here when running a test with cargo. And this is one of the things I noticed with Rustlings is it doesn't really show you how to run the test. It's running the test for you. Well, either way, we have here, it looks like A, which is an array. And so we can see here that it is inferred it as an I32, but with 5 integers, which you can see here. So this is another way to write that same array that we had before. But now it's saying getting a slice out of the array so that the test passes. So what we could do here, I'll call it nice slice, okay? But then what we could do is we take A, and then we use a open bracket. And what we need to do is say what's the starting point and end point. We need to give it some sort of range. There's also open-ended ranges. So we could say like, you know, for example, this is all indexed by 0. So if I want the same exact array, I would start with 0, and then I'd go up to the very end of the array, which would be, looks like 5 here. That would be the idea. Now that doesn't work. Actually, Let's see, what is the issue we have here? Size of values, integer cannot be known at, oh, okay. It wants us to then say what the length of that array is as well. So here, let me just do this. Show you that this is an open-ended array, right? Oh, did I do this wrong? Let's see. Size of the array, size not implemented for integer. Must be statically known. Yeah, okay. So we would say it's an I32, but then with 5 again. Yeah? Okay. Oops, not n. A.len. Nope, okay. Yeah, for some reason I'm doing this wrong. Let's actually look at, real quick. Don't use a lot of arrays, and I don't slice a lot of arrays. So let's look back at the README slice types. Let's go back to the Rust book. Show you how to look this stuff up. All right, so yeah, you have your chapter markers on the left-hand side. Those links go directly to the place that you're looking for. So here they're talking about strings, but we want to look for an example of an array. Oh, yeah, okay, forgot the ampersand. Yeah. I think that's all that we're missing there. So let me go back. Make it to 5. Put the ampersand there. Let me take out the type annotation that we have. All right, so you'll see here that the inferred type, it shows an ampersand, and then it just says I32. It doesn't say necessarily the length. So you can think of this as almost like a subarray, or like it's containing like a pointer to something that's inside this array, and we don't necessarily know the size of it, but we just know that it exists. And so actually, if I was to run this, this would fail because this is not exactly what we're looking for. But if I look at the output in the test, yeah, okay. So you can see in the output of the test, it shows the left-hand side. So that is this 2, 3, 4. But on the right-hand side is the nice slice. There we go. So we have 1, 2, 3, 4, 5 on the right. Yeah. Let's see. I forget what happens if you go outside the array. Oops. Yeah, so we fail, but I think for different reasons. Yeah. So then you get an index out of bounds for the array. So, just doing it by these numbers, these are not dynamic numbers, these are static numbers, but we could do it by a dynamic number. So we could say create a range. Notice it's a dot dot, a range of a.length. So now if we go up here, you'll see we're back at our original result. Okay. But now let's actually make it work the way we want it to. So I think there's a couple different ways we can write this range. So let's get close to it. So let's say we start at index, start at index 2, but then we'll leave it open-ended, so just 2 dots. So it'll just go all the way to the end. So now we could see that the issue here, off by 1. Let me go back, 1, okay, there we go. So again, 1 is not referring to 1 in the array, it's the index of it. So skip the 0, skip the 1, or actually, no, start at the 1, the index 1, that's what that's saying, and then go all the way to the end. So that's where we get 5 here, right? So now, I believe we could do maybe -1, let's see. Nope, can't do -1. What we could do is we could do, well, we could actually do the array index, so it'd be, 0, and then this is 2, or 0, and then this is 1, 2, and then 3. So let's do that. 3. You'll see here what happens. Notice it doesn't include, right? So if we want to include, we actually have to put before the 3 an equals sign. And then that should make it work. Yeah, so that would give us the right answer here. 0, 1, 2, and then 3. This means not up into, not until 3 or till 3. It is include, so equal, include the third index there too. That's probably what I would do. Can we take slice of vectors? We can. We haven't gotten to vectors yet, but there are going to be ways to take slice of vectors for sure. And slice of strings. And actually, why don't we look just really quick? You can look ahead here. This is showing the strings. Slice of a string, string slice. And let's see here. Does it show anything else? String literals, a lot of string stuff. So yeah, other slices. Here we go. Let's see. It works the same way string slices do. You'll see use this all kind of slices for all sorts of collections. We'll discuss these collections more when we talk about vectors in chapter 8. Yeah, my frames are dropping. I don't have the best internet connection. So the audio should be okay, but my visuals might be lagging. Sometimes it works itself out. And it's about 20 seconds behind. All right, so let's leave it at that for now. We might come back to that if we want to look at more examples in the Rust book. Let's go to the next exercise. Okay. All right, cannot find value name in this scope. All right, looks like we're doing some string interpolation and trying to print out a name that's not there. Cannot find age. All right, let's take a look, see what the issue might be. All right, so now we're on to primitive types 5. Destructure from a tuple. Okay. So yeah, here's what it's saying. It's showing you another way of creating variables. And to me, it looks like we have name and probably age is the second one here. But you can destructure tuples. So see the tuple, instead of in the square brackets, it's in the parentheses. Okay. This actually does come up quite a bit using a tuple. And it's usually 2 objects, sometimes 3. You don't see many going beyond that, but when they're meant to be paired together, but you don't want to make an actual type for them, this is what would happen. So yeah, this here is just string interpolation. So it's showing you here. This is slightly newer in Rust. So maybe if you've looked at Rust years before, it didn't have this. You had to write it as a format string or something similar. This here, you could just drop in the variable name within the winged braces, and it prints out its display, meaning like when it displays to the console, what should it show? So I can see here, it displayed the correct information that it expected. So 3.5 years old. All right, next one. Okay. Let's read what we got here. Cannot find the value second in scope. Okay. Well, I see. So yeah, here's another example of a tuple where we have 1, 2, and 3. Very similar to what we had with arrays. And the second element of the number. So the second element, again, it's 0 indexed, right? So we could do numbers, dot 0, 1, 2 to get all 3. And so if we do 1, that is going to give us this second element here. So as soon as I save, you'll see that the error goes away. There we go. Something you'll notice if you're going to be writing your own test or experimenting here, this is just one file. It's the main file. You don't have to write anything in your main. You can just create this test module within the same file. And if you run cargo test, that is what makes this run. You do need to annotate each test with this test here. So you could literally copy and paste this code into your own Rust project that you created and start changing things up. But notice there is a third parameter. It's just a bonus for you all. The third parameter is more descriptive of like what you're trying to assert and maybe what your expectations are that you're trying to test. So here we're trying to make sure that the second one is 2. So they're saying this is not the second number in the tuple. Yeah, all right, so let us move on. Okay, so something about V not being in scope again. Now we are on to vectors. So let's go back here. We did the primitives. Now we're moving on to number 5, vectors. Let's look at the README before we move on. So vectors are one of the most used data structures. In other programming languages, they're simply called arrays, but Rust operates on a bit of a lower level. An array in Rust is stored on the stack. So those are the arrays that we were looking at before, that we did a slice in just a moment ago. So that is stored on the stack. And that also means that it can't grow and shrink dynamically, but you can take slices of those things. So the size needs to be known at compile time for those arrays. But now with vectors, what we're learning new is that it's stored on the heap, which allocating and accessing the information on the heap is going to be a little bit slower than storing on the stack. But you get a couple more features with that. So, you know, you can pass that around in ways that maybe you wouldn't be able to do that with arrays. And then you can also grow and shrink. If you don't know the size at compile time, then vectors is probably what it is you need. So vectors are a bit of a later chapter in the book, but we think they're very useful to talk about earlier. So that's the opinion of these people who made the Rustlings. So we shall be talking about other useful data structures like hash maps later. So yeah, a couple other links here to the book. So that's cool. Let's look at this first one and let me see what I could show you. Yes, so I'm going to start at the very top. I'm looking at this particular line here, line 2, and it says that that is an array, which totally makes sense. It's inferred as an I32 array, and it has 4 elements or 4 items. So that is known at compile time. It's written right there in the source code. That's how you know. Now it wants us to create a vector. So create a vector called v, or store it in a variable called v, which contains the same exact elements as the ones in the array. So there are a couple ways to do this. I'm not exactly sure how they want us to do this, but I'm going to show you what I would do, just so we could understand really quickly. All right, so I did vec and then : new. So this is like its initializer. So you'll see this as like a constructor in a lot of other programming languages. And it's a convention that you see a lot. Sometimes there's parameters to pass in. Let me go to the actual definition of this so you can see. So here it is, new. Underneath the hood, there is some sort of structure here for the vector to store information on. But notice its length will be 0 at this point. Yeah, and then there's a whole bunch of other things here to read in the documentation and in the book, but this is just what we're looking at now. Now, considering that it's a let, I actually can't add elements into this. So even though I've fixed the compiler issue, I've actually not fixed the testing issue that's here. So you can see up here at the top, I still don't have the correct elements in it. So this is going to come back down to some variable stuff here, but there are some methods that you can call on the vector to get the information in there. So there's a push method here. So notice I'll push, and we'll do it in order. So I'll do 10, and then I'll do 20, and then I'll do 30, and then I'll do 40. And then I'll save, but we still have issues. So the issue, if we look at the push here, got to look at its signature. Notice there's the ampersand mute, right? So and it's on self. That's that first one here, okay? I don't think we've talked about this in this Rustlings area here, but this is a huge indicator as to like, how do I correct this issue? Let's look at the compiler message and then go from there. All right, so cannot borrow v as mutable. It is not declared as a mutable, not mutable. Okay, consider changing this to be mute. Yeah, so that's what that's saying. So what that means is after let, do a space mut, mute. So essentially, this is now a mutable vector where we can push elements onto it. So we didn't know what was in it to start with. That's the idea. There are a couple other ways to create a vector. You don't have to just use new. In fact, I think maybe let's just scroll down to the next one. Yeah, here's another example. You can say with capacity. So it allocates the memory, but it still has a size of 0, or a length of 0, I should say. But its size grows to 10. So you'll notice here, 0 for the length, but the capacity is actually larger than 0. Then you can push elements onto it, but it doesn't have to reallocate more space. So that's the other thing about these vectors, is that they have to continually grow when they run out of space. So they could start out with something like 4, but then you want to push a new element on, but you have no more memory available. Essentially what's happening behind the scenes is that the vector is growing, and you might not need to know this, but it's like a resizing strategy. So it allocates a brand new vector, or I'm sorry, a brand new array in the background with more capacity. It could be 1 more capacity or more. And then it's copying the contents of this array into the new array. So if I was to push on something new here, say like 50, but it was already full because we said with capacity for 4 elements here. After this line 11, it's actually going to have to copy the array, make a bigger array, allocate more memory at the same time. So if the array was 4, you now have doubled the memory to at least 4, but then you need some additional memory. So it could be 1 or more. In this case, I believe vector at this small of a capacity is just 1 more that it's allocating. So it's pretty quick to do it with a small amount of elements here. And then it pushes that so that you can return. Yeah, so that's what we're doing. So yeah, there's other things that are going on here. There's subtleties that are happening that we're not ready for in this particular exercise, so I don't want to push more information into your brains. But this is essentially what is happening and how we're able to create that vector. I want to show one more way to create the vector because this does look a little weird, right? And if vectors are so common, what are some other ways we could do it? Well, we could also set it using a macro. So you do vec and then exclamation point, and then in square brackets here, you put your values you want. Okay, so these lines here, they are equivalent to the one line that I have here. It is essentially doing the same thing. So this macro, what it does is at compile time, when the Rust compiler comes in to check the validity of your code to make sure that it is actual real Rust code, it replaces all these macros with code that, you know, whatever the magic is that it's meant to do. So in this case, it's meant to say like, okay, it kind of looks at it like an array and says, you got 4 elements. I'll probably make this with a capacity of 4, add the things on it. So you never see that in the code. You just see something very simple like this. So this is usually how you see vector being used, especially in a lot of little examples. So that's what that's trying to show us there. So let me comment that out and just leave this one here. And then we can move on from there. All right, a lot of issues with this one. Let's see. All right, a couple of types. Vec I32 cannot be built from an iterator. All right, let's take a look at what the next one is trying to tell us. All right, so vex2. All right. Looks like we have a for loop, which I'm not sure that they taught us about for loops yet, but if you have a vector or an array, you would probably need to iterate through each of the elements there. So what it's saying is for, here, I'll take the type hints out, for whatever we call the element. So in this case, they're calling the element. We could also call it item. You give it its own name here, but then you say space in space and then the vector or the array or anything that you can iterate over. Then you do something with it inside this block. That's what that's saying. So inside of here. So with that, multiply each element in the input slice by 2 and push it to the output vector. So notice here we have very similar to like what we had before. We have the let mute, and instead of v, we're calling it output. So what we need to do is we need to say output dot push, and then we'll say element. So it says multiply each element by 2. So you can do times 2 there. Okay, it'll take that new value, push it onto output, and return it. So that's what that's doing. Let us look at this other part here, this example. So an example of collecting a vector after mapping. We map each element of the input slice into values, value plus 1. Okay. So just to show you what we just did above in the for in loop, usually it's like a for each is what you want to think of this as. What we're doing down here in this input.iter.map, we're really doing the same thing, except we're using some functional methods here. So map means iterate through every single thing in the for each, and you could transform the element into something different. So it's essentially the same thing as what we're doing here, but the only difference really is that we're doing the element plus 1. Now the syntax is a little funky because we haven't even talked about closures yet. I don't know that we should go into that, but this is where you name your element or your item, and then this is it using it. So whatever the output is of this, it stores it back into like kind of like what you see here, like pushing into a new array. But that's not the last thing that you can do. You have to call this collect. So that's also a convention here too. So collect takes whatever you're iterating over, and now it has a bunch of instructions, whether it's map or some other method after iter. It takes those instructions and then collect constructs it all. So it takes the instructions, looks at them, puts it all into a vector for you. And yeah, that should be that. All right, but let's look at this to do here. Okay, so here we also want to multiply each element in the input slice by 2, but the iterator mapping instead of, with iterator mapping instead of manually pushing. Yeah, so this is our example. And all we need to do here is element times 2. My formatter put it all in one line again, but just so you can see, it can be separated on multiple lines. It doesn't have to be one like that. So yeah, that works. All right, the tests, I don't think it's valuable really to look at the tests, but that's what they are. Cool. And it looks like we're done with that part. Nice. Okay, so today so far we've done primitive types and vector. Let us just take like a quick pause, because if you're learning something new, your head might start to hurt. So it's good to take a break. You know, drink some water, have a snack. Maybe, you know, take some breaths. So if your head's hurting at this point and you're watching this and this is like your first exposure to Rust, totally normal. I won't necessarily introduce reasons why, but just know that you're probably learning. So you might have to go back and redo this. But I think in the bigger picture of this, I think the thing that this is trying to accomplish with Rustlings is that we're trying to not only visually learn and auditory learning, but the kinetic learning. So you're touching, you're hitting the keyboard, you're hearing the clacks. You're like building this muscle memory in your fingers. So that's the idea here with something like Rustlings, and also the 100 exercises in Rust, which was a previous stream series that I did. Yeah. All right, I think that's it for the little break. Let us keep going. Okay. So now we're going into move semantics. All right, let's look at move semantics. This is a good one. This is maybe different than a lot of other programming languages. You start thinking a little bit more low level when you get to move semantics. All right, so this exercise is adapted from, all right, cool. So maybe check out that exercise here from this YouTuber, or not YouTuber, GitHub user. And then let's see, Rust tutorial. All right, cool. It says thank you. All right, we got to talk about ownership, referencing, and borrowing. Yeah, all right, real quick. So this is sometimes the tough concept. The compiler is really great at helping you with this. Sometimes the compiler is going to tell you a message, but your answer is not necessarily what the compiler is telling you the error is. Might sound confusing, but this part of Rust, I think, just takes practice. You just need to try stuff out. I don't think it's useful to just watch a video and then be done with it. I think a video is a great way to start, but if you're going to do any of these exercises, definitely do the ones around ownership and referencing and borrowing. Also, seeing some examples of maybe how I solve it in this particular exercise. I'm not sure what to expect. I've never seen this before. Maybe that'll help you. Yeah. And there's going to be some things maybe you pick up on the way I talk as well about borrowing and references and things like that. So yeah, there are quite a few things at play here all at once, and they all come together into this like ownership model. So let's see. Let's move on to the first one. Let's see what we got. All right. So fix the compiler error of this function. All right. So what I'm seeing, I'm going to look at the test first. We have this fill vec that we want to use, and it takes a vector. So I guess they're calling this vec0, and then they're passing it to fill vec. And then out of fill vec, we get a vector1. Okay. Now it's saying just fix the compiler issue, and I feel like the fix is pretty easy, but in terms of ownership, maybe we should be talking about what's happening here. So when you're creating vec0 and then you're handing it off to fill vec, you're passing ownership to it. And this is how you know. If I was to try and print out vec0 down here in the test, we'll get an error. And this is like probably the easiest error to see. So you see it says the borrow of the moved value vec0. Value borrowed after move. And that's because this here, this macro, I think is trying to borrow it essentially, or trying to use it in some sort of way. Another way to do this too, if I put this here, if I rearrange the code, this actually does work, because what's happening here is that it looks like a function. It's called a macro though. This is actually borrowing the value, and it's not taking full ownership of it, which means that the ownership still exists like in this scope, and then it's passing it on to the fill vec function. And then see, I try and use it again afterwards, and I still have the same issue. So no matter what I do with vec0, I just can't use it after I've given ownership of it to fill vec. So how do you know it's like passing ownership of it? Here, I'll fix this part here. That is because you can look at the signature here for vec. And then what we're doing here is we're creating just our own little, basically our own variable vec. So we're reassigning it the variable. So here, I believe if I just do mute, that fixes it. So we could pass in a mute vec. I'm not even sure actually that would work. Yeah, wouldn't work. But before we get to that part, this part I think solves the problem. So that's one thing. But what it's doing, it's actually not pushing on to the original vector, because we own the vector. So we're essentially just, adding on to this. So you see here, 22, 44, 66. So if this is mutating it internally, that's why you don't want to be able to use vec0 later. It kind of gets complicated. I think reading the book also helps with this as well. There might be other ways we could talk about move semantics, but I think right now, just knowing that vec0 passing in to fill vec now takes ownership of vec0. I think that's the key thing they're trying to show you here. So I did solve the issue here by making this now mutable. But when I make it mutable, essentially we're saying, since we own this thing, it's okay to do that, and we can make something new and push it onto something else. So now we create this new variable. This is that new variable here, vec1. So they're actually separate. I think that's what we're trying to say here in this exercise. All right, let's move on to the next one. Well, actually, let me just double check. Yeah, we're done. Okay, so we'll move on to the next one. All right, same setup. It looks like they used mute just like how I did there too to push on this new value 88. Let's look at the test. So make both vectors vec0 and vec1 accessible at the same time to the compiler. Oh, to fix the compiler error in the test. Yeah, so there's a couple ways to do this. And actually, my editor is kind of giving me hints at what we could do. So, this takes ownership of vec, right? But maybe we don't want it to take ownership of it. So let's see what the errors say, because the errors usually are pretty helpful. Yep, borrowed. Let's look at this hint. So moves occur because vec0 has type vec32, which does not implement the copy trait. So that's interesting, right? So vector doesn't implement the copy trait. What could that mean? That means fill vec is taking ownership of vec, But if it was a copy value, like just a regular number, it wouldn't necessarily take ownership. It would take ownership maybe of the variable, but what we're trying to say is it would take a copy of that. So there is no copy of the vector being made when passing to fillvec. That's what that's kind of saying. Let's take a look here. I think this is maybe the same thing. Yeah. Okay. And then let's look at the function signature, though. Consider changing this type parameter of fillvec to borrow instead of owning the value if the value isn't necessary. What that's saying is let's do something like this. Put an ampersand in front of it. Now we have some different errors that come up. So maybe read them from the call site just so we can see here. So it's a mix match of types. Because it is a vector of I32, but then this is saying it needs to be a borrowed version of that, we can just put an ampersand in front of this, and that'll work. I think another way we could do this too, maybe we could do the ampersand in front of this macro. Let's see. Yeah, that works as well. Let me put on my type hints so you can see what's happening. Let me take away that. Okay. Now this is where we put the ampersand. Yeah. So either way, this works. So this is effectively, you're starting to use the borrowing system here. So you're saying, okay, fillvec, you can borrow a vector. And then we're actually making it mutable and then pushing something onto it. But now we need to, if you look here, we have another issue. So let's look at what this issue is. So it's a mixed match of types. So it expected, see vec here is a borrowed version, right? But it expected that vec be not a borrowed version. So there's a couple of ways to do this. Does it have, yeah, two owned? That would work. Well, it fixes that issue, but we have a different issue now. And that would be, yeah. Now we're starting to get into deeper areas of owned and unknown. But yeah, that's that there. So yeah, that's what that's trying to say. So we want them both to be accessible at the same time. So you might think, oh, if it's borrowed here, return borrowed there. Maybe. Let's see. Okay. Yeah, we're still getting some issues. So if you look here, now we're getting, yeah, the star. Cannot borrow as mutable. That is, it has a bind to the ampersand, a reference. So yeah, this is where things get really tricky really fast. I think probably what we want to do, actually, let me put that back in. Let's see. So probably what we would want, I'm trying to think here, was what is the solution that they're looking for? Accessible at the same time to fix a compiler error. Yes, yes, yes. So I think that fixes that error, but it doesn't fix the error that is up here. All right. Yeah, that doesn't work there. All right, this is where I think maybe just to double check, because I don't want to necessarily lead you guys astray with extra stuff. Let's look back at the solutions. This would be move semantics number 2. Oh, these are my solutions. Okay. Oh, interesting. I thought this was the solutions to the actual assignments. Interesting. All right, so let me go back into this. Oop. Number 2, yeah. Cool. Let's see if the hint helps us. All right, so when running the exercise for the first time, you notice that the error is the borrow of the move value in Rust. The argument is passed to the function is not explicitly returned. you cannot use the original value variable anymore. We call this moving. So a variable when we pass, and it's to be moved. You can't access value anymore. You can make another value instead. It's called cloning in Rust. Okay, yeah, I see. So it didn't really tell us exactly what we want to do, but I know now it probably wants us to clone. So what does that mean for this part here? Still wants us to do something here. Okay. Not exactly sure what we want. Yes. Actually, I think this is maybe what it wants us to do. Clone. Yeah, okay. So we passed in something, and then we decided to clone it, which is essentially like a copy. So it did a for each over the vector, created a new one, put it here, marks it as mutable, and then that means we can push new values onto it and return that one there. So yeah, this clone here kind of like leaves the first vector out of here. Just says we're not going to use you anymore. We're not referencing you anymore with the reference there. Yeah, so I think that is what makes it work, and that's probably what they're looking for. Let's see. Yep, exercise done. All right, cool. All right, yeah. Okay, let's look at this next one. Cannot borrow vec as mutable. Okay, so we're moving on to the next thing. Let's see what number 3 has for us. Fix the compiler error in the function without adding any new line. Okay, no new line. So I think what we want, so we're not adding lines of code, but I think we're gonna have to change the function signatures. This looks like to me, we're gonna do this. Whoops, nope. And then this is saying do clone, whoops. Yeah, I think that works, but then this here needs to be a borrowed mute. So we did borrow before, but you can also do borrowed mute here. Right? Does that work? Oh, it's not working. Oh, is it because, whoops, we need to make this mute? Borrowed mute here. Yeah, okay. So the borrowed mute, it might look like it's 2 parts, but they're really together as one. So I make the first vector mutable. We're passing it into this fill vec. This is very similar to like a C application because, well, I mean, in this case, the vector is stored in the heap. So I guess I don't know why you'd exactly do it in this particular way, but you could always return a vector, which I guess this function also does. So we're kind of using, this isn't necessarily something you'd write quite like this, but what we're doing is we're saying, okay, now what we're passing in is not only a borrowed reference, but it is mutable. So you can change what's on there. And you can only have one borrowed at a time. So I know it says not to change the other lines here, but I think this doesn't work. Oh no, it does work. But I wouldn't be able to do, let's see, if I did this twice. No, okay. Yeah, so there's an exclusivity here with the borrowed mute. I don't know if that's what that's trying to teach us right now. But yeah, But that's how you make that work. Okay, let's just move on to the next one because maybe we'll find more there. All right, maybe this is where we get into it. Yeah. Okay, all right. That's awesome. I had the right idea of what was being taught next. So fix the compiler errors only by reordering the lines in the test. Okay. Don't add, change, or remove any line. All right, cool. So fix the compiler errors only by reordering the lines. Yes, okay. So the reason why this doesn't work, actually maybe looking at what we have up here might be better. So it's saying this is the first mutable borrow here, but then we have a second mutable borrow, okay? And we're trying to push to the first mutable borrow after we have the second mutable borrow. So that is invalid. You cannot do that. So you have two things that are mutable. Like how do you guarantee consistency with, if you push onto, like this is like Z is basically like aliased reference to Y, but now you push something to Y, should Z also have the 42? It gets a little ambiguous and unclear, I think is what they're trying to say. So if you do it beforehand, that actually should clear it up. So you can push new values onto it. So now you consistently know that Y is no longer being used. So now you can reference X again, okay, with a mutable, exclusive mutability, and push 13 onto it. So you should have the 42 and then the 13. Whereas it's unclear if it came after. A lot of other languages will let you do this, but Rust does not let you do this. Yeah. So that's actually a big one. Okay, so next one. Okay. Number 5. Okay. Fix the compiler errors without changing anything except adding or removing references. The character ampersand. Without changing anything except adding or removing references. Okay. Let's start with main. All right, so we have a string. This is one way to make a capital S string. Very similar to vectors. It is stored on the heap. So that's the capital S string. And now we're passing ownership to chars, or get char, which is probably get character, yeah. So we passed ownership to it. So now we got the characters, which is probably a character. Okay, well, it looks like it's its own type, but it's maybe, you could think of it as like maybe a vector of some kind. We get the last thing, which probably returns an option, yeah. Okay, and then we're unwrapping it. So force unwrapping, a lot of concepts built into here that if you're just learning Rust for the first time, this might not make too much sense here. So we're really looking at just the ownership model here. And this is saying it shouldn't take ownership. So if that's the case, we could do this. It seems that works because none of these things like mutate the object. You're just reading information from it. So I think that makes sense. But now this one, the string to uppercase, is saying it should take ownership of it. Okay, because we're passing in a mute data. Okay, passing in a mute data, yeah. Which means you can mutate the data that's passed in instead of returning it. I think that's what that's trying to say. So now if that's the case, now we can ampersand here. So you can give it a reference to the data. But now this is mutable, so you don't want to take reference to this data here. But it does take ownership. So now it basically took what was data, made it a mute data. Okay, that means nobody else outside the scope of this function is going to touch it, which is totally fine. So we're going to change its value, point back to its value in the heap, and say, hey, make this data change. Strangely enough, though, it's not being used anymore after this. Could we use it after this? Data. Oop. Actually, it's not a function, but yeah, this would be bad because it's borrowed after mutating. Yeah, so this took ownership of it, so we can't use it anymore. It makes sense. So as soon as we take ownership of that data, it's done. Which kind of makes the usage of this function a strange example, but we're really just looking at the variations of taking ownership or borrowing and then also mutating the data that's there. Yeah. All right, so that was 5. Okay. So that means if we move on to the next one, it's structs. And where are we at with structs? We got 3 for structs. Let me check. Enum's got 3. Strings, okay. Nice. All right, so I think that is all that we have time for today. I don't know that we should do any more. So thank you guys for watching today, the live stream. We'll do some more Rustlings in the future. So if you subscribe and click the bell to get a notification on your phone so that you can see when we're doing this again, so you can watch. But yeah, so far so good. Hopefully, if you guys have any questions, maybe it's been cleared up with Rust, but if you have any additional questions, you can put them in the comments below. I'll try and answer them the best that I can. I also have a lot of different videos going over a lot of these concepts in the book, and it might be a little bit more thought out because it's not live. So go and watch those videos on the channel if you'd like to see them. There's also other videos besides Rust, but if you do want to learn what's in the Rust programming book, I have a lot of videos covering much of that content. So yeah. Otherwise, yeah, I think that's it for today. I'll see you later. I'll leave you with some music.